Question 16. We are given g as being 2 cubed times 3 times 7 squared. We're given h as 2 times 3 times 7 cubed. And we are asked to express gh as a product of powers of its prime factors. So gh means that you're multiplying g and h together. So I could set up this sum to begin with. And the 2's are going to combine in such a way that 2 cubed times 2 will give us 2 to the power of 4. I don't want to actually get a number from that because our answer needs to be written as a product of powers in its prime factors. So we end up with 2 to the power of 4 from multiplying the 2's together. We're going to have a 3 times a 3, which is going to give us a 3 squared. And then our 7's multiplied together, 7 squared and 7 cubed is going to give us a 7 to the power of 5. So that will be our final answer for GH. Next part, G divided by H, or G over H, gives us a certain power of 2 times a certain power of 3 times a certain power of 7, and we have to figure out the values of A, B, and C. So in other words, what the powers of 2, 3, and 7 actually are going to be. So G divided by H, let's actually take our numbers from G and divide them by our numbers from H first and foremost. So set that up as a fraction. That's going to give us 2 cubed times 3 times 7 squared all over 2 times 3 times 7 cubed. Simplifying each of these, we have our 2 cubed over 2 is going to equal 2 squared, which means the value of A as the power of that 2 is also 2. We have our 3 divided by 3, which technically cancels out. 3 divided by 3 will equal 1, but also be careful, if we have to express this as a power of 3, you'd actually end up with 3 to the power of 0 is 1. So that means that our power of 3 is 0. And lastly, we have 7 squared divided by 7 cubed, which written as 7 to the power of something would give us a 7 to the power of minus 1. So C, our power of 7, is minus 1. Lastly, part C, show that those two things multiplied together equal 29. So show question means we need to take this and we need to end up with an answer of 29. So being careful with how we break it out. The nice thing about show questions like this is you'll know if you've gone wrong, because if we don't end up with 29 at the end, then we've done something wrong. I can't use 29 in our answer. We've got to end up there, and I've got to show all the workings clearly. So I can't just type this into the calculator and put equals 29 and be done. It doesn't work that way. So breaking out our brackets here, we're going to have a 7 times 7 for 49. We're going to have a 7 times 2 root 5 for a 14 root 5. We're going to have a minus 2 root 5 times 7 for a negative 14 root 5. And lastly, we'll have a negative 2 root 5 times a positive 2 root 5. The two 2's are going to make 4. And the 2 root 5's times together are going to make 5. And then those combined are going to make 20. And the fact that one of them was a negative means we end up with a minus 20 there. And then combining these, our 49 and our takeaway 20 equal 29. And our two third terms, are plus 14 root 5 minus 14 root 5, cancel each other out, giving us 29, which is what we wanted, which means we are done. Part D. We have 1 over the cube root of 9 to the power of 4, and we are told that it equals 3 to the power of n. So what we have here is we have an equation where a letter is in a power. And any time in IGCSE, if you have an equation with a letter in power, we follow the following steps. First of all, we look at the bases. We look at the numbers that are underneath the powers in question. We have this 3 and we have this 9. The first step is to write every single one of these numbers as the same base. So 9 is just 3 squared. So if we write all of these in terms of 3's, that's our first step completed. So if I do that, here's what I'm going to end up with. 1 over the cube root of, in a bracket, 3 squared, close bracket, all to the power of 4. On the right-hand side, 3 is just 3 to the power of 1. I don't need to do anything with that, so we still have a 3 to the power n as follows. What comes next then is on both sides of the equal sign, simplify fully using all of the indices and laws of indices that you know. So on the left-hand side, we've got a lot going on here. We have a root of a power which has in a bracket something to a power. So we've got a few indices rules here. First of all, we have the third index law involving multiplying powers. So what's there in blue ends up becoming 3 to the power of 8. We then have this cube root. When we cube root something to a power, that ends up giving us a fractional power. So when we have the cube root of 3 to the power of 8, that's going to become 3 to the power of 8/3. All of that is on the bottom of a fraction. We have this 1 over 3 to the power of 8/3. And technically, we want this left-hand side to look like what we have on the right-hand side. So I turn this into a 3 to the power of negative 8/3, bringing this term up top to make it look like, and to make it in index form. I can do that as long as I make the power negative. And what we end up from that is 3 to the power of negative 8/3 is equal to 3 to the power of n. And the last step here is to make the powers equal to each other and answer the question, which in this case we already will have done, because negative 8/3 equals n, and the question's asking us for the value of n. Done.